Now we are going to discuss another problem on Stokes' theorem. The question is, using Stokes' theorem, evaluate the line integral f bar dot dr bar, where f bar is equal to 2y square I bar plus 3x square j bar minus of 2x plus z k bar, and C is the boundary of the triangle whose vertices are 0 0 0 comma 2 comma 0 comma 0 comma 2 comma 2 comma 0. In the previous question also we have discussed the same question, but what is the difference between the previous question and this question? Now we are going to see. So here the question is given to evaluate line integral, means you will calculate surface integral. F bar, it is already given in the form of vector equation. Vertices of a triangle are given. We said that whenever the vertices of a triangle are given, from these points we have to choose that on which plane the question will be given. Moving to the solution. F bar, it is given as 2y square I bar plus 3x square j bar minus of 2x plus z k bar. The given vertices are 0 0 0 comma 2 comma 0 comma 0 comma 2 comma 2 comma 0. If you see the x values, it varies from 0 to 2, again 2 to 2. Means x is varying from 0 to 2. When coming to the y, it is varying from 0 to 0 and 0 to 2. In any one of the point, the y value and x value, it is showing difference. Coming to the z point, in the first point z is equal to 0. Moving to the second point, in z is equal to 0. In the third point also we are getting z is equal to 0. Means in all the 3 points we are getting z is equal to 0, which is common. You can say that when z is equal to 0 in all the points, the question will be converted in the form of xy plane. That is what we have written here. From these vertices we observe that z is equal to 0 is common. So we can say that these points lies in xy plane. Since line integral is given, we have to evaluate surface integral. So we have drawn a rough figure of a triangle OAB on xy axis. So here we have taken the Stokes theorem. So line integral f bar dot dr bar is equal to surface integral curl f bar dot n bar ds. So we have to calculate curl f bar on xy plane. So we have taken on xy plane, we know that the outgoing vector on z axis, it will be k bar. So we have written n bar is equal to k bar, and ds on xy plane we can written as ds is equal to dx dy. Now we have to calculate curl f bar and we have to calculate the limits of x and y. So here we have taken to calculate the limits of x and y. First we are going to calculate the limits of y. So from the figure we are going to see that you are having two variations here. From origin on x-axis we are going to take 0 to a. On y-axis we doesn't have any point, so we are having in the form of triangle. We are taking on y-axis as 0 to b. So one line equation will be 0 to a, another line equation will be from 0 to b. So you are going to take it to calculate to y. We are going to take the line equation for 0 to b. From 0 to b, the origin point O is 0, 0 and B point is 2, 2. Since both the points are different, we know that when two different points are given, we will be applying the distance formula, that is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. Substitute all the points x1, y1, x2, y2 in the above equation. On simplification we get x is equal to y. Since we are going to calculate here limits, we are not converting into the parametric form. So here we have to calculate the limits of y. This x is equal to y can be written as y is equal to x. So from the triangle we have to make it the lower limit. The lower limit, it is passing through the origin. So you will be taking as y is equal to 0 to y is equal to x. Means y limits will be converted as 0 tends to x. To find out the limit of x we have taken on the line O to A. So O we have taken as 0, 0, A we have taken as 2, 0. If you observe these 2 points, y is equal to 0 is common. We want the limits of x. X varies from 0 to 2. So directly from the points we are getting x is equal to 0 to x is equal to 2. These are converted in the form of limits. Now we have to calculate curl f bar. We know that curl f bar is given by del cross f bar. Del cross f bar we are going to define in the form of determinant. determinant. Substitute all the required values in the determinant, expand your equation, then you will be getting curl f bar is equal to 2j bar plus 3x minus 4y k bar. So this is your curl f bar equation. Now substitute curl f bar, n bar, dx, dy and with respect to their limits here. So here on applying the dot product, you will be getting integral 0 to 2, integral 0 to x, 6x minus 4y dy dx. Since y limits are with respect to x in terms of single variable, first you integrate with respect to y. On integration with respect to y, we get 6xy minus 4y square by 2. Apply the upper limit minus lower limit. On simplification, we got I is equal to integral 0 to 2 4x square dx. Now you apply the integration with respect to x, you will be getting as 4 into x cube by 3. Apply the limits, upper limit minus lower limit. On simplification, we got I is equal to 32 by 3. Now what is the difference between the previous question and this? In this question, in the previous question, when you are making the surface integral, we got only ds. So we have calculated this ds value as in terms of area of a triangle in the surface integral. Here if you observe, on applying the del cross f k bar, we got some variable equation as 6x minus 4y. Since we are having in terms of variable, we have calculated the limits here and then we have integrated the solution. In the previous question, we are getting only integral of ds, so we have not calculated the limits. Directly we have converted into the area of a triangle, and on simplifying area of a triangle, we got the solution. That is the difference between the previous question and in this question.